So in this lecture, we will be actually studying how the SSL works and how we can protect ourselves, how our account and our resources on the AWS with the man-in-the-middle attacks. So you should actually go through this lecture. So even if you know the SSL, so I will go over the basics. But trust me, there will be some new content for you. So so starting from the SSL refers for the secure socket layer, and it's used to encrypt connections, and TLS refers to transport layer security, which is a newer version of that protocol, newer version of the SSL. And nowadays, even though it's almost only TLS certificates, people still refer, including me, of it as the SSL. So if you hear me say SSL, I mean TLS most of the time. So, and it's just everyone does that. So don't get me mad at this. So public SSL certificates are issued by something called the certificate authority, and you have many public certificate authorities such as Comodo. You may have actually authorized some of the certificates from the Comodo, Symantec, GoDaddy, Global Sign, DigiCert, Let's Encrypt is the most common one, and so on. So, and when a certificate is issued to you, it has an expiration date that you will set. Surely it remains in the number of the years, 1 year, 2 year, and then you must renew it before it expires to keep your services up and running. Before like your SSL certificate will expire, and it will just show a warning or something. So it will go over the HTTP protocol. So how does the SSL encryption work? So well, how does the SSL encryption work? So well, you have a client and a server, and they need to talk to one another using a secure channel. So they need to use SSL encryption, and the thing is, using asymmetric encryption, which is the basic of the SSL, is very expensive. And by expensive, we mean like the expensive in terms of CPU cycles required to the encrypt and decrypt. So the next expensive type of encryption is the symmetric encryption. It's much cheaper, but SSL is only for asymmetric. So the idea is that during the asymmetric handshake, which is the first connection between the client and the server, they are going to use an exchange, a symmetric key that will commonly will be shared for this communication. And from that point forward, they will only use the symmetric key to talk to one another. So in this case, the asymmetric key encryption for SSL is just used for the handshake, and it's all symmetrical. So this is how does that work in the detail. So the client says, hello, here is my cipher suites, and here is the random thing. And the server responds, okay, here is my server random, and here is my SSL certificate. Then the client will verify the authenticity of the SSL certificate by looking up if it's correctly computed. And then if it is, it will send a master symmetric key that has been generated and sent, and they will be encrypted using the key that it has received. And the idea here is that this secret will be able to be retrieved by the server and decrypted. And in case the client also has an SSL certificate, it will send it at this moment. So it's possible to have a two-way certificate where the client will find it and find it gets to the server, and the server to the client. And then using the master key of the server, using the private key, the master symmetric generated key by the client will be decrypted, and we will have a secure connection here. So this is going to be the symmetrical this time in place between the client and the server, and you don't need to know all these details. The exam will not test you on this, but I want to make sure here that you understand how this handshake works, at least at a high level, so you get an idea of how SSL works. Just for the knowledge, because I think as a solution architect professional, if you don't know how SSL works, that's a bit worrying. Okay, so but the exam will not test you on this exact knowledge. So now definitely we will be actually now going on to the SSL or SNI for server name indication. So the idea is that SNI will solve the problem of loading multiple SSL certificates onto one web server only, and that will allow you to serve multiple websites from that one web server. It's a newer kind of protocol, SNI, and so it requires the clients to indicate which host name it's trying to connect to during this initial SSL handshake that we solved. And then the server will find the correct certificate, or it will return a default one if it doesn't find one, doesn't find the correct SSL certificate. And so this works for the ALB, application load balancer, and the network load balancer, NLB, which are the newer generation of the load balancer. Classical are the old classical generations, and the CloudFront, it will also work with the CloudFront. So it does not work for your classic load balancer, so which is the certainly the older generation. So very important to note here that so we have our ALB, and needs to be connected to two target group which are connected to different host names. The first one is www.mycorp.com, and the second one is domain1.example.com. You are able to see them pretty easily here. So we are going to load two SSL certificates onto our ALB, but it could be more than two also. And so one SSL certificate will be corresponding to the first target group, and the other one to the second target group. So the idea now is that a client who has SNI compatibility, that the server name indication compatibility, says, hey, I would like to connect to www.mycorp.com, and the ALB, because it has the SNI enabled, it will use the SSL, the correct SSL certificate, and then it will redirect it to the correct target group. And we'll have an encrypted connection, but in case we ask for obviously another domain, then the ALB will be here the smart enough to get the other SSL certificate and connect to the other right target group. So that would be second target group here, the domain1.example.com. So the SNI is extremely important. So as soon as you have multiple SSL certificates, and if you have a classic load balancer, then it would not work. It doesn't work with classic load balancer. So classic load balancer, and it doesn't work with the SNI. So then we cannot use one classic load balancer behind multiple applications. So you would need to have multiple classic load balancer for multiple target, for multiple ASG, in order to get this architecture working. Okay, next, extremely important, how to protect yourself against SSL man-in-the-middle attacks. So how does it look like? So we have the good server we are trying to reach, and our user is trying to talk to it, but there's a pirate server in between. And because it's a HTTP right now, it's a HTTP protocol right now, it can intercept the packets and can change them at will. And so it's in the middle, and it can see the secrets and so on. It's really bad. So this is never happening on the web, because there's almost no more HTTP protocol being used nowadays, and now HTTP available. But if you do have HTTP on the web, be very careful, because you are public. You can be a target of man-in-the-middle attacks. So now the good way is to use HTTPS protocol. So we have the same kind of architecture, but this time the pirate server will try to send a fake SSL certificate to the user. So by decrypting the packets from the good server and re-encrypting them, and maybe changing them, and so if the user is not infected, it's going to detect it's a fake SSL certificate and not react to it, and just say, okay, I am not communicating with that pirate server. But in case the pirate server did manage to get onto the user's machine and make the pirate certificate trustable by the user, then the user will say, oh, this look like it's a certificate that I trust, and the pirate server has successfully done a man-in-the-middle attack. So how do we prevent the man-in-the-middle attacks? So number one is, do not use public-facing HTTP servers. Use HTTPS protocols. That means that you leverage SSL and TLS certificates, and that means that the content is encrypted between your clients and your servers. That doesn't prevent the second vector of attack, which is to have a DNS attack. So if you are using a DNS that has a DNS sec enabled, DNS security enabled, that means that DNS is going to be protected against the type of the attacks as well. So well, when a DNS server is hacked, or is possible for a pirate server to force a DNS response and to send your clients to the wrong target server, but you can protect against that by having your domain name configured with DNSSEC. So Amazon Route 53 supports DNSSEC for domain registration, and as of December 2020, it also supports DNS security, DNSSEC for DNS services itself using KMS, Key Management Service. So both domain registration and the DNS service are now DNSSEC compliant on Route 53. You could alternatively run a custom DNS server on EC2. For example, one of them could be Bind, which is the most popular. But you have other ones, which is DNS mask, not DNS, Power DNS, and configure DNS directly on your custom instance. But right now there's a change, and Amazon Route 53 supports DNSSEC out of the box as of the December 2020, and we are here at the July of the 2022, so it's available. So that used not to be the case. Alright, that's it for the lecture. This lecture, I hope you liked it, and I will see you in the next lecture.